Okay, everyone. Well, what was that? The whole thing disappeared. Oh, there it
Okay,
is.
never mind.
Okay. Welcome back to SAT Math Question of the Day with the illustrious Professor Emeritus Seth Chaiken from University of Albany and his brother trying to do some math, Joel Chaiken. We're here to try to help you understand how to do the math SAT questions, but more importantly, how to approach these things. So here's our math our SAT math question of the day. SAT goes first. Okay, which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? So, do you remember we talk about the different modalities of thinking in an algebraic equation, the modality of table, graphing, or the algebraic equation itself. And in this case, it's definitely helpful to think graphically. Graphic is a good modality here. There's the graph, x, y. Y is greater than or equal to -1. So, that means that you want a function that is above, this is -1, this is 1, this is 1, this is -1. Okay, you want a function that is above this line. And wait, it's equal to, so this is a solid line, big, thick, solid line, right? And you want a graph whose function fills this space. So you look at these things.
But better yet, does not go below the space.
Absolutely not. It does not go below space. That's because y is greater than or equal to -1. So you look at these things. What is greater than? Well, certainly C. C is always positive, right? C is always positive. C is possible. This one here, that one there, a little complicated. How about this one? This one.
Okay. Let's see. In the SAT, when they ask for which, well, let me just check this. Is there always only one answer, or are
Yes,
there questions in which?
No. Yeah,
okay.
no. Yeah,
okay,
no.
So once you found a response that satisfies the question, then since the SAT does not include responses that don't satisfy it, you're done.
Right.
You don't even have to look at the others.
Yeah, I guess you're right. But that takes a lot of, I don't know, naturally one would think that one should look at something. It's just to be safe.
Yeah, naturally one would think that one should look at them. But, what you did was you noticed immediately that the value of y in all the points of the graph given by the equation in C, you notice that value is always greater than or equal to 0. And greater than or equal to 0, anything greater than or equal to 0 is always greater than or equal to -1.
Right.
So that C satisfies the problem.
Yeah.
But I think it is helpful when you're doing the SAT to when you find and are pretty sure that you've gotten an answer that satisfies, you're done with the question.
Right, yeah.
Right.
So Seth is using test-taking logic, right? But
it doesn't hurt.
Right. But it takes a lot of confidence to approach this problem and just look at it and say, I'm done. And it takes a little bit too much confidence than most people would have. Seth is taking logic, but it doesn't hurt to spend 15 seconds checking out the other answers.
Okay.
Okay, anything else to say?
Well, I would differ from you. I think that to check the other ones, it's more helpful to use the algebra and properties of arithmetic, rather than try to plot each of the others.
Okay.
So let's look at A. Well, A has this -2 sitting there, and the absolute value of x. So what you need to recognize is that is that when x is 0, the absolute value of x is 0, so y is minus 2, which is less than minus 1. So that's no good. Similarly, your eyes kind of sketch around and you see, with your glasses, x squared minus 2. Well, it's the same thing. X squared could be 0, so that's no good. That's not an answer because y could be minus 2. Similarly, you see an x cubed. Okay, well, same logic. If you pick x equals 0, you get a negative 2. However, when I first noticed this, when I first looked at it, what I thought of is that y cubed is an odd function, and basically, more specifically, here let me think of what the plot of y cubed is. Y cubed looks like that. So it goes down to negative infinity on the left-hand side. So it gets very, very, very negative sometimes. Even if you subtract 2, it gets even more negative. And so D is certainly not a correct response.
Right.
So that leaves me with C. In fact, when I first saw the problem, I approached it this way. I looked at A and B, and then I saw C, and then just because I couldn't resist the temptation to test response D, I thought of this visualization here.
Right.
So I used a combination of modalities.
Right, that's right. That's how you have to do it. And it's really helpful to practice these things, to try to think in parallel, to try to think in the modalities in the same time. I know it takes a while to sort of feel comfortable thinking in different modalities at the same time, but the brain is capable of doing it.
Yeah, but the more you do it, the more comfortable it'll be.
Right. Okay,
I think we nailed that one.
I think we're basically done. We're going to bid everyone goodbye, but I want to mention after, if this is optional if you want to listen, I just want to go over quickly how you're supposed to graph these if you have to do it quickly using transformation of functions. This is classic 11th grade math. I'm sure you saw it, but it's not a bad idea to review that, but that'll be an optional thing after we say goodbye to everyone. Okay, thanks for watching. Please like us, dislike us, leave comments. We really would love to hear what you have to say because we want to make these videos as good as possible for you. Okay, so if you want a really quick review on how to graph these things, let's do that. That is classic 11th grade math, and it's not helpful. It's helpful to remember how to do that stuff. It has to do with the parent function. It's very popular. I don't remember when I went to school they taught this stuff, but they must have. Did they talk to you? Seth, did you ever hear about the word parent function before?
What's the adjective there?
Obviously, again? Seth graduated high school from Brooklyn Tech High School in 1969.
High School, yes.
Never heard of the parent function. Well,
parent. Parent.
Parent.
No.
You never heard of the parent function. Well, this is the way it's taught now. You have these parent functions. And these are 3 of them. These are 3 of them. So you're supposed to know that the y is equal to the absolute value of x is the absolute value function. This is really annoying, isn't it? This is the absolute value function, and its graph is this thing. Goes like this. Okay? That's called the parent function. And if you want to do y is equal to the absolute value of x minus 2, then because it's a minus 2 there, you take this parent function and you move it down 2 spaces. And that's how you do it. So you take the parent function and you transform it based on what's going on. If you have y is equal to the absolute value of x minus 2, that's a transformation where you take this parent function. I will write it this way in orange, right? This one goes 2 units to the way you think, the opposite way you think it should go. If it's a minus 2, then it actually goes plus 2. Okay, and then this one graphs.
Why didn't you draw it?
That way.
Yeah,
okay.
There we go.
Right. Right. So
Right.
that's the way it's taught.
Very nice.
So that means, but in order to play this game, you need to know the graph of the parent functions. So the absolute value, this is the absolute value function. The square function is y is equal to x squared. That one is a parabola. It goes like that. Okay. Seth already did the cube function, right? Seth knew the cube function. So you knew about parent functions without even knowing about parent functions, right? Y is equal to x cubed goes like that.
So the parent function differs from the child function in that the child function is gotten by displacing the graph of the parent either vertically or horizontally.
Right, and sometimes you put a factor in. Sometimes you may put
Wait,
a
hold
form
on. What about both? What if you
Yeah,
have,
of course. And a stretch. There's a stretch factor.
You could displace vertically and horizontally.
Of course, and you can add a
That's parent,
stretch to
too.
it. You can add a 4 to it. If a 4 to it, then it goes faster, right? If 4 goes to it, it goes, it goes faster. Whoa, faster, slow. See that? So you can you take the parent function. I don't know. I thought people are into this stuff before graphing calculators, because before graphing calculators, it's easier to do this. Now everyone has a graphing calculator, so it doesn't really matter. Like you just plug whatever you want in the graphing calculator, you get the answer. So that's that. So that's how you graph these things really quickly using parent functions. It's a good review. Anything other comments? And then the y is, that's interesting though. The one that the actual answer was y is equal to x minus 2 squared, wasn't it?
Right.
Wasn't that it? Yeah. So this one is the parent function, y is equal to x squared, but then there's a minus 2 in there, so you move the thing over 2 units this way.
Yeah.
And that's the graph of y is equal to x minus 2 squared. This is the graph of y is equal to x squared, and that's how you do parent functions. So, any other comments, Seth? You want to say anything else?
No. I just can't help suggesting that you take displace it downward by 2. Put a minus 2 after the x minus 2 squared.
Right. Of course we can do that. We'll put it in red.
Yeah, there we go.
So then it goes down there.
All right. Yeah. And that one is also satisfies the SAT question, because the SAT questions asks you to select functions where the y value is always greater than or equal to minus 2.
I think actually it was -1.
Right.
I think it was actually -1.
So do a -1. All right. Change the 2 to a 1. Yeah. There we go.
-1.
Yeah. So still true, even though y never attains the value -2 with that function.
Right. Yep. Okay. So that's a review of how to do parent functions. But yeah. So again, thinking in different modalities is really important.
Yeah.
Okay. Have a great day.
Good.
What's that? Anything?
Nope. Thank you.
Okay. Great.
Good
Have
day.
a great day then. Take care, everyone. Bye bye.